You do something like number 11, it says find the sine of theta equals 1/2, and this specifically says find the first quadrant version in radian form. Okay, so if you're saying the sine is 1/2, that means you're heading upward. You're heading upward the short distance, which means it's a short triangle. A short triangle in the first quadrant has a denominator of 6, and since it's in the first quadrant, its numerator is just pi. So pi over 6 is what we're doing. These things here are degrees. This just specifies the fourth quadrant. That just specifies the second quadrant. You go on to something like this, and I don't know. Well, I guess we'll start with the first one here, and I'll say that sine of root 3 over 2 in the second quadrant, from pi over 2 to pi. It's positive in the second quadrant. It's positive in first and second. We're talking about sine, and you're going up. You're going up the great distance, so it's a tall triangle. But it's a tall triangle in the second quadrant. That means the denominator is 3, and since it's in the second quadrant, the numerator is 1 less than the denominator. 2 is 1 less than 3. Okay, 2 pi over 3. Now, if we've already pictured that triangle at root 3 over 2 in the tall triangle, we're asking for the cosine of that same place. What's the x value? Well, it's in the second quadrant, so it has to be negative. And since the y value is root 3 over 2, the x value that goes with that is negative 1/2. And since I have sine and cosine, it's pretty easy to come up with the tangent, because the tangent is the ratio of sine over cosine. So if I do root 3 over 2 over 1/2, the 2's are going to cancel. I'm left with just the square root of 3. Okay, over 1, but you don't necessarily need the over 1. Now secant is a pretty easy deal because it's just the cosine flip-flop. So we've got a negative 1/2. You flip that around, it's a negative 2. Cosecant's a little bit more of an ordeal because when you flip-flop the sine, in this case it's root 3 over 2, it becomes 2 over root 3, okay? And you have to rationalize the denominator. So that means you got to multiply by root 3 over root 3. The reason you do that is because root 3 times root 3 is equal to 3, square root of 9, which is 3. And the numerator is just 2 times the square root of 3, and we can leave it like that. We have to leave it like that. And lastly, the cotangent is the inverse or the flip-flop of the tangent, so it's really 1 over root 3. Rationalize that the same way you did the previous problem, you end up with a root 3 over 3. And these are all done the same way. I would pay special attention to the fact that here you're given a tangent of theta equals negative 3, and here you have a tangent of theta equals positive 3. That's going to help you to come up with your sine and your cosine values, but keep in mind in this case here, this is the fourth quadrant version. This is the second quadrant version, and shame on me, glad I mentioned this. That's a negative 1/2, so this should be a negative root 3. So again, that is the same as that, but they're in different quadrants, so I'm going to let you try and figure out what implications that might have.